Okay, ladies and gentlemen, you are all welcome. Please, can you hear me clearly? Can you hear me? Hello, can you hear me? Hello, can you hear me? Good evening. I hope you can hear me. Are you with me? Okay. So, good evening all, and we are all welcome to Biochem 241 tutorial. And I hope you do enjoy our lectures, and also you are following. Please, let me just ask like a general question. Please, are you okay with the way we are taking our lectures? Are you okay with it? Because this is very important. Are you okay with the way we are? Okay, yes, I am okay. DJ said yes, okay, yes, sir, yes, sir, okay. So remember, ladies and gentlemen, I think I sent you video today early in the morning on the cellular transport. So that is what we are going to discuss today. So what is cellular transport? Let me ask this question. What is cellular transport? So remember, when I send you a video, is for you to watch, and after you watch, you come here and then we discuss. So now, what is cellular transport? What is cellular transport? What is a cellular transport? What is a cellular transport? What is cellular transport? This is biochemistry 241. What is cellular transport? You don't know the meaning of transport? Cellular transport. What do you understand with cellular transport? I already sent you the video on cellular. Okay. Cellular transport, it means, is the means by which molecules enter and leave the cell via the cell membrane. Brilliant and excellent. Cynthia OB. This is a very good definition. Then Sunday route is the transport of substances across the cell membrane, which can be active or passive. Yeah, I think this definition is also very brilliant. Cellular transport is the movement of substance in and out of the cell through cell membrane. Brilliant. I like all these of your definition. You are correct. So a cellular transport is a process that involves the transport of substances in and out of the cell. And how many types of transport system? What are types of transport system? What are the types of transport system? Shafa'at, Abdullahi, Sharifat, you are all good. Yes, we have three types of transport system. So please list them. Cynthia Obi, you mentioned that we have three types of transport system. Excellent. No, mention them together, Obi. It's not only passive and active transport. Okay, excellent. Idara Friday. We have active transport, we have passive transport, and we have bulk transport. So these are the three types of the transport system. So now the question is, how many types of how many types of, okay, what is passive transport? What is passive transport? What is passive transport? What is passive transport? What about saying it is a passive, active, and mixed transport? Please, sir. Is it a correct that way? No, it's passive, active, and bulk transport. Okay, passive transport is one that doesn't require energy and protein carriers. Excellent, excellent fact. A passive transport is a type of transport that transport molecules without the need of energy, protein carriers, or protein channel. So that is passive transport. Is the process by which materials enter and leave the cells without the use of energy. Awanuruddin, this your definition is also correct. So now, why do we transport substances in and out of the cell? First, we define transport, that is cellular transport. And then we talk about the different types of transport. We have three. We have active transport, we have passive transport, and we have bulk transport. So now, why do we need why the need for the transport of substances? Why the need of the transportation across or in and out of the cell? Why? Why do we need the transportation of substances in and out of the cell, please? Excellent. To maintain homeostasis. To maintain homeostasis. That is one of the major reasons why we need transportation of substances. And very importantly, ladies and gentlemen, remember our cells need nutrients because as normal human being, we take food, we take oxygen. So the organelles of the cells and the entire cells, they remain healthy, they remain active because of the nutrient that are getting in, utilized by the different organelles to generate energy, to generate other biomolecules that are required for the growth and development of the cell. So that is why we need to transport substances. Like for example, let me give us example with glucose. When we take carbohydrate, we digest carbohydrate into glucose and other monomers. Then the carbohydrates, it is the end product of carbohydrate that is required by our cells to metabolize for energy and other molecules required by the body to survive. So that is why the glucose usually, when we digest it, is usually in the blood. And from the blood, it will be transported to different cell types. And then from the cell types, because they are not, because when we have intracellular and extracellular environment, so mostly the glucose are at the extracellular environment. So therefore, they must be transported from where they arise from outside the cell and into the cell. So that is the importance of the transport. You need to transport nutrient from out of the cell and into the cell. And after you transport the glucose, of course, there will be metabolic processes. And at the end, there is waste product, or there are waste product. And those waste products, like carbon dioxide, need to be excreted. So that is why the carbon dioxide need to go out of the cell. And then the glucose need to go into the cell. The oxygen also need to go into the cell. But as you said, why do we transport substances in is for us to maintain the homeostasis. Is for us to maintain homeostasis. That is to maintain equilibrium. So now, let me ask you, I send you the video. I send you the video. We take drugs. We take drugs. Now, who can tell me must come something across the cell membrane? So the question is, what is the nature of the drugs? Is it lipophilic? Is it hydrophilic? Is it hydrophobic? That is the question, because we need to understand. Okay, can you hear me now? Please, can you hear me now? Okay. Excellent, excellent, excellent. The answer is lipophilic. The answer is lipophilic. So why is it that the drugs is lipophilic? Why is it that pharmaceutical industries, while synthesizing the drugs, they synthesize it as a lipophilic? That is the question now. Why? I agree with you. For easy absorption? No, it's not for easy absorption. For fast absorption? No. Yeah, I think Sunday Root said because they are non-polar molecules. Yes, they are non-polar. That is why they are lipophilic. But now the question is, okay, so it can be absorbed directly into the cell membrane. Excellent fact. That is the answer. You see, that is why we have different route of drug administration. There are drugs that we need them to reach into our systematic circulation very fast. So that is why we take intravenous. We have oral, we have intramuscular, we have different types of drug administration. There is a different route of drug administration. So why is it that most of the pharmaceutical drugs are lipophilic in nature? Because the cell membrane, it is a lipid soluble bilayer, so that any lipophilic molecules or lipid soluble substances can easily diffuse into the cell. Because if the drugs are not lipophilic, let's see, hydrophilic or larger, it means that before the drugs get into the cell, they will need energy, they will need a protein channel, they might probably need a protein carrier, and it's of time. Because it can come a situation where the patient doesn't have enough energy. So that means that the drugs will be difficult to get into the cell. For easy permeability into the cell membrane, excellent, that is the answer. So that is why the drugs are made as lipophilic in nature, so that when we take the drugs, they can easily get into our cell. But let me ask you this question. Where is the drugs metabolized? Where do you metabolize drugs? Which organ do we metabolize drugs? Which organ do we metabolize drugs? Excellent, liver. So the name of the liver cell is called hepatocyte. So where do we specifically metabolize drugs in a cell? Which organelles of the cell metabolize drugs? Excellent, Idara Friday. The answer is smooth endoplasmic reticulum. So that is why before drugs is metabolized, it must be passed through the cell membrane and get itself to smooth endoplasmic reticulum where it is going to be metabolized. And remember, we have even drugs metabolism. How many phases do we have for metabolizing drugs, please? How many phases do we have for metabolizing drugs? So you see, ladies and gentlemen, we are going first. We start with the cellular transportation. I ask you what is the cellular transport, and you define it. And I ask you what are the types of transport system. You mentioned them three. We have active, passive, and bulk transport. And after that, then we now also ask why is it that the drugs are lipophilic in nature, and you answer it because the drugs need to be easily passed into the cell through cell membrane to reach smooth endoplasmic reticulum. So you are saying that we have four phases of drugs metabolism. Mention them. What are those four phases of drugs metabolism? What are those four phases of drugs metabolism? Please mention them. Absorption, distribution, metabolism, and excretion. So you see, it's not four. These are pharmacokinetics. These are pharmacokinetics data. Absorption, distribution, metabolism, and excretion. So now I'm talking about specifically metabolism. What are the phases of drugs metabolism? What you are mentioning is adimate. We call them adimates, and they are called pharmacokinetics data. So I'm just talking about the metabolism, one of the pharmacokinetics data. What are the phases of the drugs? Truly speaking, we have two phases of drugs metabolism. We have conjugation, and before conjugation, we have oxidation. We have oxidation, and then we have conjugation. These are the two phases of drugs metabolism. The first phase is oxidation through cytochrome 450 enzyme. Yes, the first phase, making it hydrophilic, that is the oxidation. And the master enzymes for making the drugs hydrophilic, that is water soluble, because first, the drugs is lipophilic, that is lipid soluble. So it must be converted into hydrophilic, that is water soluble substances. And that is why we call the step oxidation. And the major enzymes that catalyze this oxidation of the drugs is called cytochrome P450. Please know this. Know this. There are two phases of drugs metabolism. Number one, oxidation, and the second phase is called conjugation. Is conjugation. Yes, that is to make it non-toxic. So you have to conjugate it. So how do you make it non-toxic? By adding conjugating molecule. So these are the two phases. And the master enzyme, there are two phases for drugs metabolism. Number one, we have oxidation using cytochrome P450 enzymes. And then the second one is conjugation. That is to make it non-toxic. So you have to add conjugating molecule. The conjugating molecule, excellent blazing, conjugation and oxidation. So these are the two phases, oxidation and conjugation, the two phases of drugs metabolism. You know that, ladies and gentlemen, drugs is generally toxic and we don't want it to stay in our body. So whenever we take it and it actually carried out it is pharmacological activity, so we need to excrete it. So first, drugs are lipophilic, so we have to convert it into hydrophilic through oxidation using cytochrome P450 enzyme. And then the next thing after you do that, then it will be conjugated using a conjugating molecules. And after the conjugation, and then the next thing or the last thing is to transport it and then finally excrete it. So this is a process. Sorry, oxidation is a process that involves the combustion of lipophilic drugs to hydrophilic using a master enzyme. And the master enzyme is called cytochrome P450. And this enzyme is located in the smooth endoplasmic reticulum. Smooth endoplasmic reticulum. That is why it's because the enzyme, because the enzyme is not there, even if it is there, but it is remaining inactive. So if the enzymes is inactive in the smooth endoplasmic reticulum, the drugs will not metabolize. So that is why the drugs is metabolized in the liver, because cytochrome P450 is in the smooth endoplasmic reticulum. So that is what we call actually compartmentalization. Some organ will do this work, cytochrome, then 450. Look at agula formulae. So cytochrome P450, that is the name of the master enzyme. So now my question is, what is first pass effect? What is first pass effect? John Annie, I sent the videos already. So here we are just discussing. Because we are nurses, so that is why I'm trying to give you versatile knowledge. You watch the video and then you come here for the discussion. What is first effect and bioavailability? Yeah, first effect is a pharmacological phenomenon in which a medication undergoes metabolism at a specific location in the body. No, Sharifat. Okay, let me now give you example. When we take drugs, is it all the drugs that reach into our systematic circulation? When we take drugs, is it all the drugs? Is it all the drugs that reach into our systematic circulation? Excellent. So it's not all the drugs that reach into our systematic circulation. So the amount of the drugs that are available or that make itself available in our systematic circulation is what we call bioavailability. While the remaining drugs that, let's say now we take 20 gram, or let's say 20 milligram of the drugs. And at the end, maybe only 14 milligram of the drugs reach into our systematic circulation. So that is what you call bioavailability. When you take a drugs, so the amount of the drugs that make itself available in the blood circulation, excellent, Eunice. So the amount of the drugs that make itself available in our blood circulation is what you call bioavailability. While the amount of the drugs that doesn't get itself into systematic circulation is what you call first pass effect. Yes, so first pass effect is not every drugs that we take that 100% of it will reach into systematic circulation. So the amount of the drugs that make itself available in the blood circulation is what we call bioavailability. And those amount of the drugs that doesn't get itself, the percentage of the drugs that yeah, it's of course it depends on the route. It depends on the route. That is why sometimes if you want to get your drugs to be readily available to carry out its pharmacological activity within a short period of time. That is why it is always advisable to go through intravenous. Look at the antimalarial drugs. There is a meter. You can take a meter, but at the end, you can take a meter as a drug, but at the end, it might not actually work perfectly. But if you take the injection, because it is intravenous, so it can easily get itself into systematic circulation and get itself into the cell, and before you know it, it can clear the malaria parasites. I hope you understand. So, do you now understand the meaning of bioavailability and first pass effects? Please do now. Okay, now you understand first pass effect and bioavailability. The video will be available because we need to pass this stage. So now, for the passive transport, we have how many types of passive transport? How many types of passive transport do we have? How many types of passive transport do we have? Okay, three. So mention them. What are the three types of passive transport? Okay, please, ladies and gentlemen, let me make my point very clear. Uh, don't forget I told you that I have a group tutorial where I taught anatomy, biostatistic, human physiology 225, human physiology 227. I have all the videos available. I have all the videos available for these 5 courses. And as I mentioned last time, that all the videos for biochemistry will be made available. They are all available for all the students. But for human physiology 225, human physiology 227, biostatistics and anatomy, you need to register with the YouTube membership if you are interested. You can see like Shafiu Salmat and so many others here that you consider there, like Sunday Root. If you look at her name, Kuru Elizabeth Iyelila, Odolale Adejoke, Hawa Aliyu Kira. If you look at their names like Salifu, Halima, Victoria, Okoraji, if you look at their names, you see that their affairs, their colors is not the same. So I wanted to tell you that if you really want to enjoy my video on biostatistics, physiology, the two physiology courses, and anatomy, try to register with the YouTube membership so that at least you can have access to all those videos. And we already started with the tutorial, and of course all the videos are available in the YouTube. So I advise you to try to register with the YouTube membership if you are interested for the tutorial, if you are registered for the tutorial. And don't forget, I told you that what I want actually is just 1,500 or 4,000 per month. So you can register with just 1,000. It's not up to 2 gigabytes data price. So it is better actually you enjoy the videos and you start as early as possible so that at least you will have a very good grade. So that at least you'll have a very good grade. I'm sure if you are following my videos and you are following our discussion on WhatsApp group, I'm very sure if you are following us, you'll get a very good grade. So you shouldn't spend much of your money and at the end you end up having bad grades. We suffer biochemistry, the human physiology 225, human physiology 227, all the videos are available. So I will advise you to try to register with the YouTube for the biochemistry and you can always watch them. So that is what I want to say. So if you are interested, you can register. Please, can we have the link registration on WhatsApp so it will be easier for you for okay. No problem, I will send it. In fact, even from here, if you check, you will see join. So if you click on join, you will see the prices. You can see 750, 1,500, and 4,000. So if you want to register with 1,500, and I will advise you don't register with anything uh, less than 1,500. So if you click on 1,500, then click on join. No, YouTube doesn't receive transfer, doesn't accept payment through transfer. It accepts using ATM card. So when you see join, click on join. It will require you to input your details of the ATM. Then 1,500 will be paid into your account. But I'm telling you, it's very important to register. It will make your learning easy. It will make the program to be much more easier for you. So we have diffusion, we have osmosis. I've also registered for the YouTube, but have not been able to get the video. Please enlighten me on how to start watching. No, it's simple. Provided if you are not in my YouTube channel after this class, you can chat me. So, like for example, tomorrow we have human physiology 225. So you see Okonko just joined and you are welcome. So if you are not in the YouTube, if you are not in the if you are not in my uh WhatsApp group, I usually send videos. So we followed a timetable. We have a timetable. So we followed a timetable. Tomorrow we have human physiology 225. So early in the morning, I will send videos for human physiology 225. And after 8 p.m., we'll come to the group and we'll be discussing based on the videos you watch. And then after like having 2 or 3 lectures, then we'll get past question paper. We'll ask question based on what we covered. So that at least whenever you are going to write your exam or you are going to write any quiz or any assignment, you can easily do it. So that is how we do it. Please, will the video always be on the YouTube so we can always watch after subscription? Yeah, of course. The videos are always on the YouTube, provided that you make that payment. So if your on is 750, you can still click on join. You can see 1,500 and 750. So click on 1,500 and make payment. So if you already pay 700, so another 750 will be removed, and that will make off the 1,500. So the videos will, okay, sir, if we register with 1,000, are we going to get all the videos for biochemistry? Even if you didn't register, you will get all the videos for biochemistry. They are free. They are free because I am assigned to teach you. I'm taking it as also, I'm tutoring the course. I'm assigned by DLC to take the course. So biochemistry is free. Biochemistry is free. I make my point very clear. When it is expire, you will not be able to watch the video. So you need to pay again. I'm talking about physiology, the 2 physiology courses, the biostatistic and anatomy. So these 4 courses, except biochemistry, it's only when you make payment you can watch them all. But for biochemistry is free. For biochemistry is free. You don't need to make payment to access biochemistry videos because DLC will pay me for what a subgroup tutorial you can join, so that at least whenever you are interested, whenever you are there, we have a timetable that we are going to follow. So I'm finding it difficult to join, please. Yeah, use, if you try your ATM card and it's not working, you can use your friends and register. So now we have osmosis, we have diffusion, we have facilitated transport. So now, what is osmosis under passive transport? Simple diffusion, facilitated diffusion, and osmosis. So what is osmosis? So I think osmosis is simple. It's a movement of molecules from the region of higher concentration to the region of lower concentration through semi-permeable membrane. That is what you call osmosis. So the movement of molecules from the region of higher concentration to the region of lower concentration through a semi-permeable membrane. While diffusion is a movement of molecules from the region of higher concentration to the region of lower concentration. So you see the only difference between diffusion and osmosis, the diffusion doesn't require semi-permeable membrane, while osmosis require a semi-permeable membrane. So the drugs that we are talking about, yes, it is auto renewal. And whenever you want to stop it, you can stop it, you can cancel it. So drugs that we are talking about applies which types of transport? Does it apply simple diffusion, osmosis, or okay, see Chinwe Akwegu also registered with the membership. Osmosis is a transfer of solvent from a region of higher concentration to a region of lower concentration through a semi-permeable membrane. Yes, Ulelu, that is osmosis. But now the question is, which types of passive transport? Because of course, from the definition, because membrane is a lipid soluble layer, and then the drugs is also lipophilic, so therefore definitely is passed through simple diffusion. Sorry, it passed through passive transport. But specifically, which types of passive transport? Is it osmosis? Is it diffusion or facilitated diffusion? Which one? Please answer me. Excellent is diffusion. So what is facilitated diffusion? What is facilitated diffusion? So I am finding it difficult to join, please. So maybe after the class, you can chat me private and then I will ask the problem that you are facing. So that is what is facilitated diffusion? What So what are the types of co-transport? What are the types of co-transport? So a co-transport, it falls under facilitated diffusion and is when you have two molecules moving at the same time. That is co-transport. And this co-transport is divided into how many types? So I'm confused because which study materials are we in the course materials? We are still under cells. Unipod, antipod, and sympod. Excellent Idara Friday. You are doing excellent Idara. Excellent. You are doing a very good job. So what is sympod? What is sympod? What is sympod? What is sympod? Two molecules moving in the same direction as at the same time. Excellent. So sympod is when you have two molecules moving in the same direction. That is sympod. So who can give me examples of molecules that use sympod transport system? Examples of molecules that use sympod transport system. Excellent. Glucose and sodium. So glucose and sodium get into the cell at the same time. So glucose on its own, it cannot get into the cell. While sodium also on its own, it cannot get into the cell. So therefore, and sodium. Okay, can you hear me now? Hello, can you hear me now? Can you hear me now? So what is antipod? What is antipod? What is antipod? That is the question. What is antipod? What is antipod? What is antipode?
Absence of comprehension regarding biblical.
What is antipode? What is antipode? Okay, so excellent. Antipode moves two molecules in opposite direction. So when you have two molecules move in opposite direction, that is what you call antipode. So now who can give me examples of antipode? Examples of molecules that transfer or that move through antipode transport. Excellent. Sodium and potassium. Sodium and potassium are examples of molecules that undergo antipode transport. So that is correct. So when you have sodium and potassium, that is actually when we have antipode. So then what is unipode? What is unipode transport? Unipode. So uni actually when we said one molecule. So when you have is the movement of only one molecules across the cell membrane. Excellent. So that is unipode. So now, ladies and gentlemen, apart from this, then we have active transport. So active transport is a type of transport that require energy. So it require energy to move substances across the cell. And we have two different types of active transport. We have primary transport and we have active transport. So the primary transport require ATP to transport substances, that it require energy to transport substances across the cell. While for secondary transport, it requires electrochemical gradient to transport substances across the cell. So that is what we call uh, secondary active transport. And then the next thing is bulk transport. So a bulk transport is a types of transport that move a large molecules, that moves a large particles. That is bulk transport. Remember in the cytosis, ladies and gentlemen, if you could remember in immune system, we have phagocytes. A phagocyte, it is a cell. A phagocyte, it is a cell that usually engulf a viral particles or bacteria or other microorganism. So in bulk transport is a types of transports that move a larger molecules, that move a larger molecules or a larger particles. Okay, primary active transport is a type of transport that require ATP, energy, to transport substances across the cell. While secondary transport is a type of transport that require electrochemical gradient, to move substances across the cell. So that is what we call secondary active transport. And then the next one is bulk transport. So in bulk transport, a molecules where larger particles usually move in and out of the cells using a bulk transport. So that is why I made mention that during phagocytosis, remember a phagocyte is a type of white blood cells. It usually grabbed and engulf microorganisms, and they are large. So therefore, in bulk transport is divided into two. We have exocytosis and we have endocytosis. So endocytosis is like when you have a phagocyte as a cell and there is a bacteria. So it will engulf the bacteria and then it will get the bacteria into the cell. And that is what you call endocytosis. If you watch the video, you can see even the mechanism on how the cell engulf microorganisms and get them into the cell. So phagocytes are the cells that usually engulf and clear microorganisms like bacteria. So when there is bacteria, this phagocyte will now grab the bacteria and get them into the cell. So the process of doing that is called endocytosis. And after these microorganisms are digested, are cleared, then it will now go out of the cell. And the process of taking larger particles outside of the cell is called exocytosis. So endocytosis, larger molecules get into the cell, while exocytosis, larger molecules get out of the cell. So ladies and gentlemen, these are the types of the transport system, and I hope you do understand and get the concept of this video. So I already sent the videos for you. So you need to watch those videos and you also need to watch this so that at least you will not have problem. And let me repeat myself. If you are not a member to my YouTube channel, try to register with the YouTube membership. And we have a tutorial group where we taught 5 courses. And if you want to enjoy these videos and the tutorial, you can join our WhatsApp group and try to register with the YouTube membership. The last type of transport is bulk transport, where we have exocytosis and endocytosis. So ladies and gentlemen, this is where we are going to stop unless if you have any question. This is where we are going to stop unless if you have any question. Okay, phagocytosis is a process where a phagocyte grab or catch a particular microorganism and get them into the cell. And once they get into the cell, an enzyme called lysozyme will degrade that microorganism into smaller one, so it will kill them. And after killing them, then through exocytosis, those particles will now move out of the cell. So is that clear? Please, sir, can you throw more light on oxidation and conjugation in drugs metabolism? Generally, drugs are lipophilic in nature, so they need to be converted into hydrophilic. And the process of doing that is oxidation. And the enzyme that do this job is cytochrome P450 and is there in the smooth endoplasmic reticulum of the cell. where where the enzymes at OH group, that is oxidation, that is addition of oxygen, thereby making it hydrophobic. And then after that, then it will now be conjugated using a conjugating enzyme and conjugating molecule. And the importance of this conjugation is to make the drugs less toxic. Okay, someone is asking question, how water soluble substances get into the cell? They usually get into the cell through either active transport or facilitated diffusion. Remember, in active transport, they require a channel or a protein carrier. So they can use either facilitated diffusion or active transport. So it's depend on a specific molecule. So I think if there is no any question, ladies and gentlemen, we are now going to stop, and I hope you do enjoy our lecture. So please don't forget, even if you're able to access them and you can see them. So thank you very much and bye bye. Mima Ada tried to join, Cynthia Allen tried to join, Margaret Peter, we didn't join, or Mokela or Gloria. You can also use. Okay, so thank you very much and see you next. Bye bye.